This video, I'm going to show you how to build and use the unit circle. Now, the unit circle is a circle with radius 1. The usefulness of the unit circle is if we are at a certain point on our circle, some certain point, the x at that point is the cosine of the angle theta that got you to that point. The y is the sine of theta. So it's a very helpful thing because if I know where I've landed on the unit circle, I know the cosine and the sine, and then I can build up my tangent, which is y over x. Now, the unit circle in itself allows us to know the most common types of angles that we're going to deal with, and we're going to start out with what's called the quadrantal angles. Now, a quadrantal angle is just where we've landed between quadrants. So that would be 0 degrees, or if we make one whole loop around 360, 90 degrees, 180 degrees, and 270 degrees. Now, if we go in the positive direction, that's positive 90. If we go in the negative direction, 270 is the same as negative 90. Now, because this is a circle with radius 1, we know these 4 points very clearly. This is the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So let's go around the circle and look at the cosines of each of these. That would be our x values. So the cosine of 0 is 1, the cosine of 90 is 0, the cosine of 180 is negative 1, and the cosine of 270 is 0. Now let's do the sine. The sine of 0, or 360, is 0. The sine of 90 is 1. The sine of 180 is 0. The sine of 270 is negative 1, just by looking at the y's. Now let's look when we are 30 degrees away from the x-axis. Where are we landing? Well, if we're 30 degrees away from the x-axis, you are always, because of the 30, 60, 90 triangle rules, you're going to land at the point square root of 3 over 2, 1/2. Now, as we go in different quadrants, like this quadrant here is the negative positive quadrant. So this point here, which is 30 above 180, 150 degrees, is still going to have the triangular value square root of 3 over 2, 1/2, except they're going to change sign. So that's going to be negative square root of 3 over 2, positive 1/2. Now, if we are 30 degrees below 180, we're at 210 degrees. And 210 degrees in this quadrant, since everything is negative, negative, will be negative square root of 3 over 2, negative 1/2. And then finally, if we're 30 degrees below 360, that's at 330. And that quadrant is positive, negative, so it would be positive square root of 3 over 2, negative 1/2. So all of the cosines, if we're 30 degrees away, will be related to square root of 3 over 2, either positive or negative. And all of the sines, if we're 30 degrees away, will be related to the value 1/2. Now let's say we're 45 degrees away. So if we're 45 degrees away from the x-axis, because we build an isosceles triangle, it would be square root of 2 over 2, square root of 2 over 2. Both legs are the same distance with a radius of 1, or a hypotenuse of 1. So this one is 45 degrees above 180 is 135 degrees. So that is negative square root of 2 over 2, square root of 2 over 2. And down here, 45 degrees past 180 is 225, and that's square root of 2 over 2, square root of 2 over 2, but they're both negative in this quadrant. And here, for 45 degrees before 360, that's 315, which is positive square root of 2 over 2, negative square root of 2 over 2 in that quadrant. And now we're going to do 60 away from the x-axis. If we are 60 degrees away from the x-axis, it's going to flip our 30, 60, 90 triangle around, and so our point becomes 1/2 square root of 3 over 2. Now for 60 degrees above 180, that's 120, which is the same values, 1/2 square root of 3 over 2, except the first one's negative, so it's negative 1/2 square root of 3 over 2. And then 60 below 180 is 240, which is negative 1/2 negative square root of 3 over 2. And then here, if we're 60 degrees before 360, we're at 300. And our point is still going to be related to the 1/2 square root of 3 over 2, except our 1/2 is positive in this quadrant. Our square root of 3 over 2 is going to be negative. So that's a good way to build the unit circle so that you can see what's related to what. You really just need to have this first quadrant memorized and know how they repeat throughout the entire circle. Now I would like to talk about the radian measures. Let's start with our quadrantal angles. Now the thing to remember is that 180 degrees is a pi worth of radians. Now if we remember that fact, then that's the conversion. It's basically degrees, tack on a pi, put it over 180, and then reduce. But you're just relating it to how many 180s do I have. Do I have a full 180? Do I have half a 180? So 0 degrees is 0 pi's, which of course is just 0. 360 degrees is 2 pi's, because 180 goes into 360 exactly 2 times. 90 is a half of a pi, 180 is a full pi, and 270 is 3/2 of a pi. So we write it as 3 pi over 2. Now let's do the 30. If you think about the fact that 30 goes into 186 times, 30 is a 1/6 of a pi, or pi over 6. And then 150, 30 goes into 155 times, so that's 5 pi over 6. And then 210, 30 goes into 210 7 times, that's 7 pi over 6. And then 30 goes into 330 11 times, that's 11 pi over 6. So that's how I usually build the 30s. Let's talk about the 45s. 45s are a little bit harder, but what you can think about is kind of counting how many 45s there are. Now 45 is just pi over 4 because it takes 4 45s to make 180. So you can think about the fact that those sections right there, each one of those, there's 4 of them, that takes me all the way around. So it's going to be 3 45s to get here, so that's 3 pi over 4. If I get to here, that's 4, and if I go down one more, that's 5 pi over 4. And then we get to the down here, that's 6 pi over 4, and then finally 7 pi over 4. But we can do the same thing. 45 goes into 135 3 times, 45 goes into 225 5 times, and 45 goes into 315 7 times. Now let's do the 60s. For our 60s, 60 goes into 183 times, so that's pi over 3. 60 goes into 122 times, so that's 2 of those, 2 pi over 3s. 60 goes into 240 4 times, so that's 4 pi over 3. And then 60 goes into 305 times, so that's 5 pi over 3. So that's kind of the easiest way to get the radians. Now let's do some really quick examples. So in this example, we're going to find the sine of pi over 6 using the unit circle. So pi over 6 is 180 divided by 6, or 30 degrees. So let's think about our 30-degree point on our unit circle was square root of 3 over 2, 1/2. Now remember, your x value is your cosine, your y value is your sine. So we know that the sine of pi over 6 is just that y value, 1/2. Simple as that. So if we can find the point and locate the point and memorize the point, we know lots of information about pi over 6. Let's do one more. This one says to find the tangent of -90. Now remember, if we go upward, that's positive 90. If we go downward, that's negative 90. So negative 90 is the same as 270. So we got to think about, well, what's the point at 270? The point at 270 is 0, -1. Now we know the tangent is y over x. So the tangent of -90 is the y value where we land there over the x value. Now we can't have 0 in a denominator, so that's an undefined value. So you can just use the null set, or you can write undefined. But the tangent of -90 does not exist.